So we're not interested primarily in the prisoner's dilemma, even though it gives us a nice example of using tools from game theory. We're really interested in these examples of coordination problems. But it turns out you can actually think of coordination problems as games in the way that we did for the prisoner's dilemma, and you can draw payoff matrices, as we'll see in a moment. But the games that correspond to coordination problems have a fundamentally different character from those involving prisoner's dilemmas. And that's because a crucial feature of the prisoner's dilemma is that the interests of both people in that situation are opposed. Because remember, in that example, the better one person is doing, the worse the other is. One person's success in the game is sort of corresponding to the other person's failure or misery. So for example, in the outcome where prisoner A goes free, that's the same outcome as the one where prisoner B gets the maximum number of years in prison, 3 years. So neither of them can do well in that situation without the other one doing badly. That is not the case with coordination games. And in fact, in coordination games, not only can everybody succeed together, the coordination games are games where everybody wins, but everybody has to be doing their part for everybody to win. If everybody doesn't do their part, everybody is going to suffer. In fact, in order for me to do well, we all have to do well. So again, let's look at a payoff matrix to see how that works. And what I'm going to do is I'm going to draw a very simple payoff matrix corresponding to the meeting case that we talked about before. So the case where the coordination problem is where to meet. So I'm going to imagine that for simplicity, there are just two possibilities for where we could meet. We could either meet at the subway stop, or we can meet in the square beside the movie theater. Well, imagine there's a square beside the movie theater, we could meet there. So both of us have two options. So I'm going to write me on the vertical. So I could go to the subway stop, or I could go to the square. And you have the same two options. You could go to the subway stop, or you could go to the square. But in this game, the payoffs look very, very different to what they look like in the prisoner's dilemma. Because in this game, for either of us to do well, we have to do the same thing. Because remember, we're trying to meet up, and that's what we want to represent with the payoffs. So in the outcome where we both go to the subway, we'll say we both get like an outcome of 1. So that represents a good outcome. And importantly, we're both getting a good outcome here. So when we both go to the subway, we both get a good outcome. Likewise, when we both go to the square, we both get a good outcome. In fact, an outcome that is equally good to going to the subway. But on the other hand, if I go to one place and you go to the other, that leads to a bad outcome for both of us, or at least not a good outcome. So in that case, we both get 0. So unlike in the prisoner's dilemma, one of us does well just in case the other one is also doing well. Something else that's good to notice at this point is there's kind of 2 ways for us to do well. Because there are 2 ways for us to go to the same place. But we don't have a preference between either of those outcomes. Both of them are equally good. And that represents the fact that in this game, we don't really care about where we meet. What we care about is that we meet. So as long as we are in fact meeting up, we get a good outcome. So likewise, I don't care which way we fail to meet, that we fail to meet is the important thing in both of these outcomes. And that's why, again, the payoffs are the same. So that's our first point, which is that coordination games are very different kinds of games to games like the prisoner's dilemma. Our interests are actually aligned with each other in a way that they're not in the prisoner's dilemma. Just to get a little bit more practice, let's see if we can identify some equilibria in this situation. So let's first of all ask, is this outcome, where I go to the square and you go to the subway and so we fail to meet, is that an equilibrium? So remember the procedure here is we hold fixed what one person does and see would the other person have preferred to switch. So let's first of all say, well, would I have preferred to switch if I knew in advance that you were going to go to the subway? So that means sort of deleting this column here. Because if I'm holding fixed you go to the subway, then I know that going to the square leads to this outcome, and going to the subway leads to this outcome. So if I knew you were going to go to the subway, would I have preferred to also go to the subway? And here the answer is obviously yes, and we know this because of the way we set up the case. So that represents that this outcome here can't be a coordination equilibrium, because holding fixed you go to the subway, I would get a better payoff by doing something else. So we know that this is not an equilibrium. And in fact, exactly the same kind of thing will happen here. So neither of these are going to be equilibria. What about the case where we go to the same place? Would that be an equilibrium? And here it looks like the answer is yes, because, well, let's start with me first. So if I knew in advance you were going to go to the subway, is going to the subway what I would have rather done, or would I rather have switched? And of course, as we already saw, I would have rather gone to the subway. Likewise, if you had known in advance I was going to go to the subway, is going to the subway what you would have preferred to do, or would you have preferred to switch? Again, you would have preferred to go to the subway. So this situation is an equilibrium, even though these two aren't. And if you go through, you'll see that this is also an equilibrium. So in this game, in the meeting game, there are two equilibria, unlike the prisoner's dilemma where there was just one. What Lewis notices, though, is that in this kind of game, in a coordination game, these equilibria actually have a special property. So not only are they equilibria, but they have an important further property. So what we did when we identified when they were in equilibrium was we went through each player and said, well, if you knew in advance what everybody else was going to do, would you have preferred to stick with what you're doing, or would you have rather have switched? But we can also ask a different question. Because remember, what my option leads to, what kind of payoff it leads to, depends on what you do. So here, whether we meet not only depends on where I go, but it also depends on where you go. So we can ask the question, I can ask the question for myself, well, given what I did in this outcome, for instance, given that I actually went to the subway, would I rather you have done something else? So not holding fixed your action here, but instead holding fixed mine. Holding fixed what I did, would I rather you have done something else? And here the answer is no, obviously no, because holding fixed that I went to the subway, of course I wouldn't rather you go to the square. I'd rather you do exactly what you do. So and actually if you go through the case for you, exactly the same is true. So in this outcome, you go to the subway. Would you rather me have gone to the square, holding fixed that you went to the subway, assuming that you went to the subway? Obviously the answer is no. Our objective is to meet. In this situation, that's exactly what we do. So given that you go to the subway, you would rather me do exactly what I do. So unlike just ordinary equilibrium, so in an ordinary equilibrium, you have to sort of go through each player and say, would they rather do what they do in advance, knowing in advance what everyone else is going to do? We can also ask, well, just assuming we know what I'm going to do, would I rather the other people do something else? And in coordination equilibria, you would not rather people do something else. So then we can say that there is this special kind of equilibrium. So this is what Lewis does. A coordination equilibrium. And the coordination equilibrium is a kind of equilibrium with an extra special property. And that property is that no one would have done better had any one particular person acted differently while everyone else acted the same. So we've seen that obtains here because, well, not only do I prefer to stick with my choice given what you do, but I also prefer you to stick with your choice given what I do. No one would prefer somebody to have done something else given what everybody else actually did. It's worth seeing that not all equilibria are like that. And actually, to see that, we should go back to the prisoner's dilemma. So earlier on, when we looked at this example initially, we saw that this outcome, the one of both people betraying, is an equilibrium. But is it a coordination equilibrium? Is it a case where no one would prefer some one person to have done something different, holding fixed what everybody else actually did? So given that there are just two people, that means asking, would B have preferred A to do something else, holding fixed what in fact B did? Or would A have preferred B to do something else, holding fixed exactly what A did? So how do we assess that? Well, let's start with B first. We're asking, would B have preferred A to do something different, holding fixed what exactly B did? So holding fixed what B does means ignoring this column here. Because remember, this is the column that corresponds to B betraying. And what we're asking is, well, A could have done something else. A could have stayed silent rather than betraying. If A had done something else, would that have led to a better payoff for B? So earlier we asked the question, would it have led a better payoff to A? But now we can ask, if A had done something else, would that have led to a better payoff for B? And of course the answer is yes. Because holding fixed what B does, if B in fact betrays, then of course he would prefer A to stay silent, because if A stays silent, then B goes free and A goes to prison. So this is not a coordination equilibrium. It is an equilibrium because if each person knew in advance what the other one was going to do, they would prefer to stick. But holding fixed what they in fact do, they would have rather the other person done something else. So holding fixed that B is going to betray, he would rather A stay silent than A betray, because then he goes free. And in fact, exactly the same goes for A. So let's hold fixed what A does. So A in fact betrays. Would A rather B had done something else? So what would instead would be the outcome for A if B had stayed silent instead of betraying? And here we see again, just like it was for B, holding fixed that A does what he actually does in this situation, he would rather B do something else. He would rather B stay silent, because again, he would go free if B stays silent. So again, it's overdetermined that this isn't a coordination equilibrium. It is an equilibrium, but it's not a coordination equilibrium. Because holding fixed what each person does, they would have rather the other person have done something else. And this is exactly why we want to hone in on this particular concept of an equilibrium, the coordination equilibrium. Because remember, in coordination problems, sort of the intuitive idea is we want to be kind of doing the same thing, or we want to coordinate our actions in the same way. And successfully coordinating leads to a good outcome for everybody. And we also want to capture the fact that once you've coordinated, you wouldn't want anybody else to be acting differently. So for instance, suppose the outcome of us both meeting in the subway comes about. I wouldn't have wanted you to have done something else, given what I'm actually doing. And that seems like an essential part of a coordination game. So now that we have the idea of a coordination equilibrium, it's very simple to say what a coordination game is. A coordination game, we're going to say, is a game with two coordination equilibria. So we know what a coordination equilibrium is. A coordination game is a game with two of those things. You might ask, well, why are we saying it has to have at least two coordination equilibriums? Well, the idea is that, well, it wouldn't be much of a coordination problem if there was an obvious way to coordinate. So, for example, in the meeting case, the reason why it's a coordination problem is because there's a range of different places for us to meet. That boils down to saying there are a range of different coordination equilibria. It wouldn't be a problem if there was just one obvious place to meet, like, for example, the square. There would just be no coordination problem. So we're going to say that a coordination problem is a game that involves these multiple coordination equilibria. So once we have a particular coordination game with its coordination equilibria, how do we decide what we actually do? How do we decide how to coordinate? And as Lewis points out, there are various different ways this might happen in the different cases. So one obvious answer is we might just agree. So in the meeting case, we might just agree to meet by the square, or agree to meet by the subway. So just prior agreement is a very obvious way to settle on which way to play a coordination game, which outcome to go for. But there are other ways as well, because we can imagine cases, and there are real life cases where we can't agree ahead of time, or maybe we have in fact just not agreed ahead of time. But nonetheless, we can still coordinate. So one way to do this is if particular outcomes might be very salient. So for example, in the meeting example, maybe one of the two places to meet is extremely salient. Maybe the square is just much closer to the theatre, or it's got there's a big statue in the square that we can meet by. If we can both see there's something really salient about one particular way to coordinate, even if we haven't communicated ahead of time, we might both just decide to go there. So just going by what outcomes are salient, that's one way to figure out what a coordination equilibrium is that doesn't actually require agreeing in advance what to do. A different way, or maybe just another version of salience, is just to rely on precedence. So for example, if we went to the movies last week and we met by the square, even if we haven't agreed this week where to meet, that might be a very good reason for us to meet at the square again. And in fact, you might think, well, meeting at the square last week makes it extremely salient, makes a particular outcome extremely salient. And so even if we don't communicate with each other, we might both naturally go to the square, even though we haven't talked to each other about it ahead of time. So there are at least three ways to figure out which coordination solution we're going to play for. But notice that in every case, a really crucial feature is that everybody expects that they're going to do their part. So for example, let's go back to the meeting game. So suppose we've agreed, or I'm wondering whether to try and shoot for this coordination equilibrium. Well, clearly, I will only decide to try and go for this equilibrium if I expect you to go to the subway. If I in fact expect that you're going to go to the square, this is not what I would do. I would try and shoot for here. So what I decide to do, what equilibrium I decide I want to try and bring about, is obviously going to crucially require me thinking about what I expect you to do. Because, well, we can only coordinate if we do sort of the same thing in the right sense. But when I'm trying to figure out what I expect you to do, that's going to require me to sort of put myself in your shoes and think through what you're going to do. So in some situations, that's kind of trivial. Like if we both agreed in advance what we're going to do, it's kind of trivial to put myself in my shoes because I think, well, you're just going to do what we agreed to do. So therefore I expect you, for instance, to go to the subway. But in other cases, this is more substantial. So in the case, suppose, where we've forgotten to agree in advance on somewhere to meet, I want to figure out what I expect you to do. And to do that, I'll try and put myself in your shoes and think, well, what do I think that they're going to do? For instance, I might put myself in your shoes and say, well, what outcome might be more salient? What might be a more salient place to meet for you? But of course, I know that just as what I do depends on what I expect you to do, the situation is the same for you. What you do depends on what you expect me to do. So in putting myself in your shoes and trying to figure out what you're going to do, I know that what you do is going to depend on what you expect me to do. So I'm going to have to try and sort of partly recapitulate the reasoning that you're doing about me in my reasonings about you. So not only do I have to see that, oh, the statue in the square is particularly salient to you, but I have to think that you would also think it's salient to me, because remember, I know that your actions depend on what you expect me to do. So in this way, we see that what each person is going to do in these examples depends on what they expect the other person to do, but figuring out what they expect the other person to do can involve trying to figure out what they expect you to do. And of course, you can see that, well, we can take this even further and talk about much higher levels of expectation. But that's sort of sufficient for now. So what we saw was that we introduced a particular kind of game, the coordination game, and we saw that there are kind of special coordination equilibria that seem distinctive to these games. So not only do they involve various equilibria, but those equilibria have the character that each person, for instance, holding fixed what they did, wouldn't have preferred anybody to do anything else. Once we've isolated those kinds of equilibria, we can then use them to define a game with this kind of characteristics. And we can see that in these kinds of games, whether you want to do what you do is highly dependent on what you expect other people to do. If you think everybody else is going to conform, if they're going to play their part, then you're going to want to play your part too. But if you think other people are going to defect and they're going to do other things, I think you're going to go to the square, not the subway, even though we agree to go to the subway, I'll want to do something else different too. So these games, what you want to do is highly dependent on what you think the other people are going to do.